In this video, we're going to dive into the concept of calculus. And it's so important to understand how it fits in. And so calculus has this thing called derivatives, which we're going to look at over the next few videos. But that concept of a derivative links very closely with gradient. And so to start us off, let's just have a quick refresher course in our understanding of gradient. Okay, in grade 9, we used to have just straight lines, and we could read straight from the equation and say, there's the gradient. And then what happened is we started to learn about curves, functions that are curvy. And we said, okay, well, instead of getting an actual gradient, we can get an average gradient. So we would take these points here. This point here would actually be written in coordinate form as 0 and 2. Okay, and we would say, okay, well, the average gradient then is going to be y2 minus y1 over x2 minus x1, and we could substitute, so 6 minus 2 over minus 1 minus 0, and what do we get? We get an answer there of 4 over minus 1, and so the average gradient there is minus 4. Okay, but that's the average gradient between a little space. What happens if I want to know the gradient at a point? Okay, what mathematicians love to do is they love to introduce lines that touch the graph at just one place. Okay, this would be called a tangent. And if I wanted to know the gradient here of the tangent, then calculus is going to help me achieve that goal. Now, a question that you are guaranteed to see in your exams is something that says determine f prime x, that's what we call the derivative, using first principles. Okay, and this is a formula that comes to you on your formula sheet. All right, let's quickly have a look at what this means. So when we do this, we are talking about the derivative. So basically a version of the function that can help us work out the gradients. Okay, so that's the derivative. Then we talk about the limit as h tends to 0. Okay, so I'm sure that in class your teacher would have explained this in detail, but basically what they do is they take 2 points and they move them closer and closer together. That's what this h is. It's the distance between 2 points. Okay, don't panic too much if this is all a whole lot of theory for you. But basically what they want to do is they say, how can we make this distance as small as possible so that we can actually find the gradient at an instantaneous single point. Okay, and that's the goal. And so that's why they do this whole limit thing, and they say, how do we make it as close together as possible? Okay, what we need to understand is that we'll be given a function f of x, or whatever it's called, g of x, h of x, and then we actually need to work out another function like this. Okay, and so whenever we are asked to do that, that simply means that you substitute, and in the place of x, you write x plus h. Okay, so let's work out some derivatives by first principles, and I think you'll see it is quite straightforward. All right, so here they're saying to us, determine f prime x, the derivative, in other words, using first principles. Okay, the question, if it says to you using first principles, you don't get any marks if you use any other method. So make sure you read your question. Okay, and there they give us f of x is equal to 3x squared minus 1. Okay, and then sort of a part B here. Hence is always our clue to think about what we just proved. Hence determine the gradient of a tangent to f at x equals 3. Okay, so let's just start with first principles. We'll go to our formula sheet. We'll get that formula. Okay, so there it is. Now, in order to work with this formula, I need an f of x and I need an f of x plus h. Okay, they've told me f of x, so it's not necessary for me to rewrite it, but let's do that. Okay, and then f of x plus h, what I said earlier is in the place of x, we want to substitute now with an x plus h. So that's going to look like this. Okay, and now we can actually work this out. So 3, this becomes x plus h times x plus h. And then we're going to FOIL. Okay, remember to do your brackets first. This is always sad for me when people lose marks here. BODMAS is always alive and well. So this is going to become, if we FOIL these brackets, it's going to be x squared plus 2xh plus h squared minus 1. And then let's put that 3 into the brackets. And so we end up with 3x squared plus 6xh plus 3h squared minus 1. So there we now have an f of x, that, and an f of x plus h, that over there. Okay, you can work it all out in the fraction, that's okay too, but I have found that students make fewer mistakes if they do this quick calculation here on the side. Okay, so now what we want to do is we want to, for as long as there is an h in this little expression that I'm working with, I have to write the limit. Okay, so don't forget about that. So limit is h tends to 0. We're going to substitute it out with the 0 just now, but for now, there's still lots of h's happening here. Now we're going to take f of x plus h, so that we worked out there, 3x squared plus 6xh plus 3h minus 1 minus that whole f of x, so minus 3x squared minus 1 over h. Okay, let's multiply that minus in there. So we'll end up with limits. We still got h's in this expression. So 3x squared plus 6xh plus 3h squared minus 1 minus 3x squared plus 1 over h. Okay, now if everything's gone according to plan, we should be able to cancel things, or they'll technically a plus and a minus, they'll end up negating each other. We should be able to get rid of everything that doesn't have an h in it. Okay, that's our secret goal here in this step. Okay, so limit is h tends to 0. Now, I might be tempted, if you have a look here, I'm just left with this, 6xh plus 3h squared. I'm tempted just to substitute in the 0, but I'd be left with something undefined. And so what I have to do now is I have to factorize. Okay, I'm not allowed to just sub in there, I'll run into problems. So let's take out a common h in the numerator. So we're left with 6x plus 3h over h. And now that and that can cancel. So now technically I've got limit as h tends to 0, 6x plus 3h. And now in this next step, I'm going to substitute. So I don't need to write the limit because I'm going to get rid of that h. So 6x plus 3, and in the place of h, a 0, because that's what we want. And that is just going to give me a derivative there of 6x. So that, I can tell you the gradient at any point on this slope is going to be 6x. And so now if they say to me, hence, determine the gradient of a tangent when x is equal to 3, I can actually work that out. So I've got this function here, f prime x, the derivative, and that is equal to 6x. And so all that they're actually asking me for is the derivative at that point there when x is equal to 3. So now 6 times 3. So I can tell you at that point, the gradient is 18. Okay, and that's one of the very cool applications of calculus. Let's try a slightly more challenging one. So determine f prime x using first principles if f of x is equal to 5 over x. Okay, so our formula, we'll get that from the formula sheets. And that formula reminds us that we need an f of x for this formula. So f of x is equal to 5 over x. And then we need an f of x plus h. So in the place of x, we're going to sub with x plus h. Okay, there isn't much more I can do there in my side calculation. So let's jump straight into substituting this into the formula. Okay, limit, don't forget that, as h tends to 0 of, in the place of f of x plus h now, we've got this 5 over x plus h minus f of x, 5 over x. And that is all divided by h. Now, what I want to do is I want to get a common denominator here in the numerator. Okay, so there's one thing, there's one thing. So let's make the LCD x times x plus h. Okay, so that's now going to be limit as h tends to 0. Okay, all of it's going to be over h. But this denominator here, x times x plus h, Okay, and now this first term here has an x plus h, so it needs to multiply by x. So that's going to become 5x minus this second term here has an x, it needs an x plus h. So what I do to the bottom, I do to the top. So minus 5 times x plus h. Okay, don't be tempted to cancel. We've got a minus here. Okay, that would also be working backwards. So let's multiply that minus 5 in and see what we end up with. So limit as h tends to 0, we've got 5x minus 5x minus 5h over x times x plus h, and all of that over h. Okay, this is good. The x's are going away. So now we've got minus 5h over that whole thing, and then it's divided by h. Okay, whenever I sit in this situation where I've got so many fractions, I like to then say, okay, let's write this as a division question. So limit as h tends to 0 of minus 5h over x times x plus h divided by this h here. So this I'm going to change now. This one here I'm going to rewrite as divided by h. Okay, that's technically h over 1. And the reason I like to do that is because then I can do what is known as tip and times. So let's just get a bit more space here. So limit, we're still dealing with h's, hey? So we're not throwing anything away here. Limit as h tends to 0 of minus 5h over x times x plus h multiplied by, and now that's going to become 1 over h. Okay, so what's happening here is we are going to be able to cancel. Okay, I've left this part here in the bracket. You can multiply it in, but I always like to leave it to this point because there's always a chance that maybe if it's already factorized, we can cancel something later. Okay, in this instance, it wasn't necessary, but what we can cancel is this h here with that h there. Okay, so what are we looking at now? We've got limit as h tends to 0, and then we're sitting with minus 5 over x, let's put it in now, x squared plus xh. Okay, because there's no more need to cancel. And now at this point, I can substitute in that 0. So in the place of 0, I'm going to say, in the place of h, I'm going to say, well, okay, minus 5 over x squared plus x times 0. And then what we can do is we can say that simply becomes minus 5 over x squared. And there we have it. So using first principles, we have managed to take this function here, and we have managed to get a derivative function here where we can now work out the gradient. Now, for interest's sake, if you think about this, we should know at matric level that something like this is a hyperbola, right? And so now, if I wanted to know the gradient of a tangent at any point, if I was to add a line here, I could use this function. So let's quickly do that. Let's say we want the tangent when x is equal to 10. So then we're going to say f, we know what f prime of x is. Okay, that's our derivative that we've just worked out over x squared. Okay, so let's work out at 10, what are we looking at? And this is going to be something very small, minus 5 over 100, which is going to simplify to minus 1 over 20. So when x is equal to 10, which makes sense, it's going to be far down this little arm here, the slope is going to be very small.